Okay, I'm back. Still me. So, this talk is a kind of an extension of the former talk. Can you all hear me? Okay, cool. Okay, so this is an extension of, it's not a model extension, it's a talk extension. It's something that you usually don't find in the same form in other frameworks. It's not completely specific to Odoo, but you usually don't find it in this way. Okay? So, I'm going to looking for, is he there? I don't know. Okay. It's the same URL for the pad, so if you still have the pad for writing questions that you had the talk just before, you can just reuse it, okay? I'll leave it a few more seconds in case you need it. And then I move on. Okay, let's move on. Okay, computed fields, it's something we use a lot in Odoo. In the business code, uses it a lot, but what's that? So, let's focus on what they're used for, what's their purpose. And the computed fields, essentially, it's kind of something like a formula. So you have code executing some sort of computation, and you may access to the result of that formula like a regular field. And it's exactly like a spreadsheet where you have cells containing explicit data, values, and some cells are defined with a formula, and the formula is kind of the code, but the cell itself just shows a value. So when you get to the cell, you get the value, and you can reuse actually that cell in another formula. So it's going to actually pass the data along, and you're going to use the result of the first formula and the second formula to determine its value, and so on and so on. It's really like that. Think about the computed fields like in a spreadsheet formula. And here, what's specific, it's not just something that's computed in the user interface. It's actually defined by the model explicitly. So it's part of the model in terms of model view controller. It's not in the view, it's not a controller, it should be part of the model. And that's the point, is that it looks, I'd say, from an API point of view, it's just another field. But from behind the scenes, it's actually a computation that's hidden behind, okay? And the trick is that the value may or may not be explicitly in the database. In most cases, it's not in the database. It's just a formula that's computed on the fly, okay? So, how does it look like, those computed fields in some popular ORMs? So, with a colleague of mine who actually prepared most of this presentation, we've been through a set of, whoops, looks like this, oh, sorry. We've been through a bunch of other ORMs and tried to write down what a computed field looks like and what are the properties of that computed field. So, going back to Django, which is a very popular ORM in Python, essentially what you have is simple Python property, which means it's just a computed attribute. So when you access discounted price on an object, it actually applies the formula and returns the value. It's just like calling a method, except it looks like an attribute access. That's the only difference. But besides that, it's not really a field. It's simply something like a getter method. It's computed on the fly, it's read-only, you cannot update that thing unless you define a setter on it. And it's not in the database. It's just kind of pure code. If you want to store the value in the database and maintain that value up to date, basically you have to do it on your own. You're on your own. And it becomes quite complex. And so it's manual code or potentially database triggers or things like that. Here's another example. So we've taken Entity Framework Core, which is Entity Framework for C#. And it looks pretty similar. This is also something that looks like a computed field. It's essentially a getter method. And like the other one, by default, it's computed on the fly, read-only, not in the database. Okay, so the point of having the value in the database is that in case you want to use some external tool to extract data from your database directly, that information will not be there. You will have to somehow reproduce that logic in your tool. If it's there, then it means you can really extract it like regular data. So again, it's essentially a getter. As there's no explicit support for maintaining a storage or whatever, you have to do it on your own. In Java, one of the popular frameworks, Hibernate. And this is an example which looks pretty much like the former ones. So this is a getter, essentially. This is declared explicitly as a transient field, which means transient means not really in the database. It's kind of a pseudo field, and actually its value is defined by a getter method. Sorry. So again, not stored in the database, computed on the fly, just like that. Okay? But in Hibernate, you have the possibility to define a field defined by the formula. And what the formula is, it's actually an SQL expression. So we're already somehow a step above the simplest version below. It's not stored explicitly in the database, but essentially, if you're making through, of course, the ORM's API, you're searching for data, and you're searching with some conditions, data that satisfy some conditions, and you have conditions on discounted price. Typically, the framework will actually replace the field reference, which doesn't exist in the database, by the SQL formula. Okay? So it enables still to make complex queries, to search over those fields, but you're somehow limited by what you can do in an SQL expression, which can be very powerful, but it can be quite complex as well. It really depends what you want to code, but it may be complex. But then that complexity is completely left out to the database engine. Okay? So this is what you have somehow on the market, and Odoo is slightly different. In Odoo, the same example looks like this. So all examples before, but essentially the same thing. So you had a model for a product with a name, a price, and a discounted price which must be computed. In this case, we declare the discounted price just like a regular field, and the difference, the difference is this parameter, the compute. It basically gives the name of the method that performs the computation. So when you want the value discounted price, the ORM knows that it has to invoke that method, discounted price, and provides actually the record on which you ask for it here. It can actually provide more records. I'll tell you about that. And self is a collection of records actually. And for each, it will compute and then assign the value of this thing. So this will not update the database because actually there's no database equivalent. There's no a database counterpart, I mean. However, we actually maintain a cache of what we've read from the database. And in that cache, we have what we've read from the database. We also have stuff that's not explicitly in the database. So when I execute the method, the value will simply be put in that cache. And so when I want to access it afterwards, it's there. The result will be in memory. So the computation is managed by a method which assigns the value to be computed on a collection of records. It's computed when you need it. If you don't need it, it's not computed. It's cached. That's convenient, actually, in code. It avoids to recompute the same thing many times if the computation is costly, and it's not stored in the database by default. And something you may have noticed, you have a decorator there that depends. Essentially, you declare what your formula depends on. Essentially, that's somehow the inputs of the formula. If the inputs of the formula are modified, the value of the field is automatically discarded from the cache. So we make an invalidation such that the next time you go and look at that field, you'll get an up-to-date value. It's going to be recomputed immediately because it's no longer in the cache, simply. Okay? Yeah, I'll tell later another interesting bit about that. This is the same definition. So essentially, if I go back, look at the transition. The only thing that changed is store true. What this does, essentially, the field is still a read-only field, but it's now part of the database. When it's computed, its value is put in the database, and so when you simply read the value of that field, you're going to fetch the value that's in the database. You will only recompute it when the dependencies, so what the formula depends on, has been modified. In that case, the database is modified accordingly. Okay? Those are kind of different trade-offs in terms of how many times you access the data versus how many times you update the data. If you read the data very often, and if the computation is complex, it might be worth to store it in the database because then it's easily accessible. And it's also accessible for doing other things directly in SQL. Okay? And I'll show you an extra bit. So here, hop. It's not only stored in the database, but now it's even no longer read-only. So a non-read-only, so an editable computed field, actually we have two forms of them. One of the forms is that this method is a kind of an implementation of a getter. You can provide a method that implements the inverse function somehow, or something like a setter. So you may actually define it editable and define a setter, so when you set the value of that field, it actually potentially updates actually the inputs of the formula. That's the idea. Or there's another form where you say, it's computed, but you can actually write any value on it. And this is useful to say that if you create a record in that model and provide an explicit value for discounted price, then we put that value in the database. In case we don't put a value, you don't put a value, then the framework will use the value of the other fields to compute that field such that you have a value in the database. So that's kind of a computed default value. And if you modify the dependencies without giving an explicit value to discount price at the same time, it's recomputed to maintain the value up to date. But if you provide an explicit value, you got their value. Though this is a kind of very convenient way of performing some sort of default value computed from other fields. Okay, so the field will be recomputed whenever the dependency is modified, but the field itself is not updated. In that case, the dependency is modified, we update automatically the field itself. You can play a lot with the dependencies, so you can have a field that depends on data that are actually accessible through various relations in the database. So for instance, here I'm writing something like the total on something that looks like a sales order on which I apply a global discount. Well, you write it like you would write it in plain Python. And what happens is you have the sales order depends on sales order lines. This is the line IDs. This is the dependency. This is the line IDs you find actually here. And actually, if you modify the subtotal, so one of those, if you modify it on some line, the framework will have to figure out what are the sales orders for which I have to recompute the total. And so you essentially have to follow the inverse relation to figure out, if I modify a line, which sales orders are impacted. And of course, depending on the kind of relation, you might have here, in this case, if you modify one line, you'll modify one sales order, because the line belongs to one sales order. But if you modify a record, you may have to actually recompute thousands of records, potentially. Okay? And actually, the framework does that for you, automatically. It also has facilities for computing the values, so that's the formula, which is optimized if you have to compute it for many records. So it's exactly the same computation, but in case you have sales orders with thousands of lines, essentially this API essentially say, okay, look at the sales order lines corresponding to the records I have here, group them by sales order, and sum the subtotals by sales order. Essentially, you're making the whole computation from the database, get back the results, and then put the final result in memory, from which they may then be pushed to the database to make that field up to date. Okay, I'm going to go quick because I'm running out of time. We have something called related fields. Essentially, it's a special case of computed fields, but that's very convenient. Essentially, you can see here, it's basically the value of a field that's one or several relation away. So here, for instance, you're traversing a foreign key and pick the field size on the other mall. And that's what you call the company size. And same from company name, whatever. And related fields, actually you can define them as a compute method pretty easily, and it's almost, I mean, this is almost the code you would use. And it may be non-stored or stored. It may even be inversible. So you can, if you set the value, it will set the value on the foreign object, and so on. So this is a facility. And I'm going to quickly show you why we're making computed fields such a big deal. The trick is that when you define a view and you want something in the view to be automatically updated when you modify one of the values you've put there, it's quite common in many frameworks that you have to somehow plug a hook to say, oh, when you modify that slot, maybe make a callback or something like that to update the slot below. So if you modify a subtotal on a sales order line, make sure you update the total right away. So you don't have to click on a button to make sure it's exactly like in a spreadsheet, okay? If you modify a cell and that cell is used by a formula, where the formula is defined, the value is automatically updated, right? The form views work, actually, they work automatically when the formula is a computed field. It really works like a spreadsheet. I can make a very quick demonstration. So here we define a sales order. I'm going to take one of those there. So here, if I'm modifying the quantity of that product, look at what happens here and here below when I click there. This one is automatically recomputed because it's simply a computed field. I will not show you the code, but I have the code on hand. But essentially, this is a computed field that depends on this field, and this is a computed field that depends on those fields. And actually, there's nothing in the view, there's really no code in the view to tell you that there's something to recompute. Actually, the framework adds automatically this information and provides the necessary hooks to the client side, so to the JavaScript running there. It knows that when you touch some of those cells, it has to call something on the server, and the something will return you what you have to update on your form view. It's automatic. You don't have to worry, you don't have to code that explicitly. Okay? So it's completely generic. Of course, you know this sentence, with great power comes great responsibility. The main drawback of that thing is, of course, it can fire back if you don't pay attention of what needs to be done. So if you have many records that have a computed field and they all depend on a common third object, and you modify that one, if the computed field is not stored in database, then essentially keeping it consistent with respect to its dependency, it's just a matter of invalidating some cache. It's not very costly in terms of performance. But if this value must be in the database, then we have to make sure to update that thing. So it requires potentially many updates, but you also need to find back from that record, how do I determine who depends, which records depend on that one? Because those are the ones I have to recompute. I will not recompute everything, but I have to know what to recompute. And what to recompute, it's costly to determine what to recompute as well. Okay? So that's one of the things which may be a performance bottleneck potentially. And I'm done here. It's 3. I will not answer, thank you. Thank you very much. I will not answer questions right away, but I'll be available outside the room if you have some. So I'll leave the room for the next presenter. Thank you very much.